afternoon and good morning to everybody, wherever you're joining from, and welcome to today's webinar, which is dedicated to valves for the LNG market. My name is David Shaw. I'm Applications Manager for Control and Isolation Valves at Trillium in Elland, and I'm joined today by Jiske van Dura, who is Business Development Manager for Redpoint Alloys, our specialist valve company in the Netherlands, and Sebastian Vermeulen, who is the Product Manager globally for our pressure relief valve products. So today's agenda, after we give a brief overview of the Trillium organisation, we will cover the liquefaction process. We'll dive into market trends for the LNG process and also the valve industry within the LNG process. We'll look at safety valves with a couple of case studies. We'll look at control valve product range that is used within the LNG applications, again with a couple of case studies. And we'll look at our Redpoint isolation check gate globe valves, again with some case studies particularly relevant to LNG and cryogenic applications. So Trillium Flow Technologies, if you've not joined one of our webinars before, is a global company. So each of the highlighted sites you see on the map is actually a manufacturing or service center. So we have factories located globally around the world. So to focus in on our valve brands that to cover today's webinar, we have Atwood and Morrell engineered isolation and check valves, which are based in Massachusetts in North America. We have Batley valves, which are based in the UK, and they are high performance butterfly valves. We have Blateborough control and severe service choke valves and control valves. We're based in Elland in the UK with additional manufacturing within China and Korea. We have Hopkinson's parallel slide gate and power valves manufactured in the UK and also in China. We have Saracen and Sebim pressure relief and pressure safety valves for oil and gas, nuclear, LNG market, located in the north and south of France. And we have Redpoint Alloys in Netherlands. So just to give you a brief overview of the history and timeline of Trillium. So we're a relatively new company, just over 5 years old, but actually the companies that make up Trillium have histories spanning over 190 years. So you can see here on the timeline of key dates when certain brands started production, and also key dates in the evolution of the individual companies. And this evolution is still continuing today. So you can see on the timeline there 2 of our newer acquisitions. In 2020, Redpoint Alloys joined the Trillium family with their range of fast turnaround specialist isolation valves. And then in 2022, Thermomechanical Pompe in Italy joined Trillium to add their high technology pump line. So just to point out, during the webinar, you feel free to ask questions at any time. There's a questions and answer tab within the webinar facility. And also, please try and maintain the webinar in full screen, as this will present all the graphs and illustrations properly. And with that, I hand over to Sebastian to talk about our pressure relief valves and the LNG process.
Thank you, David. So yes, as you said before starting on product review, I think it's quite important to define what means LNG, as there is a lot of process involved to get this methane, because LNG is the first methane. It's part of alkane family. As you can see, here are some mind-blowing statements to emphasize just how confusing all of this term can be. Since on one hand we have LPG. LPG means stand for propane and butane, which are all qualified as natural gas liquid that define first a group of hydrocarbon, including ethane, LPG component, and pentane plus. All these products are byproduct of natural gas processing and refining. All these products are NGL. But all NGL are not and LPG, so a quart. On the other end, we have LNG, the one we will talk about today. So as I already said, it's methane. It's what is left over after most of the natural gas liquid are stripped out from the natural gas stream. So LNG stands for liquefied or liquid natural gas, as the name implies. And the complexity here is to cool down to its point of liquefaction. As we can see, it's easier to have butane, propane, ethane, whose boiling point is lower than methane. So it's a complete process. The reason why we liquefy it, for those who are not fully aware, it will take up about 1/600th the space that the same amount of gaseous natural gas would take up. So it's mainly for transportation before regasification for public usage. So it's mainly used as a fuel for domestic, international, industrial use. So let's have a look on the complete liquefaction process. Again, we don't go too much in detail, but the idea is first to understand where safety valve globally, safety valve as I'm safety valve representative, can be localized. So it's a simplified overview of the complete liquefaction process. And as I said earlier, if you look at the temperature, you will not cryogenic is only occurring at the end of the process. So initially, we start by the gas receiving and metering station, where raw gas and hydrocarbon liquid condensate arrive via pipeline system. So to the gathering station, we will have a slug catcher whose function is to separate the feed gas stream into liquid condensate on one hand and raw feed gas component on the other end. At this stage, free occurring water is separated and removed during this process. After that, we have acid gas removal. As the name implies, the main function is to remove all sour gas components. In this category, we will operate with a specific material, can be duplex or nickel alloy. The idea is to remove sour gas applications, so it can be H2S, carbon dioxide, carbonyl sulfide, also known as COS, from the raw feed gas. Arrive compression. So gas compression can be supplied driven by steam or can be driven by steam or gas combustion turbine. The function is to boost the pressure of the purified gas to allow further processing to take place. And it is combined with a deshydratation unit where the idea is to dry the sweet gas. When leaving the acid gas removal plant, it will be from its saturated water vapor. Hydrocarbon processing is the one additional stop. Here, sweet dry gas pass through a series of heat exchanger, also known as a chiller, where it is cooled by evaporating liquid propane refrigerant. So here we start the cryogenic process as we go from ambient temperature down to minus 45 degrees Celsius. So it's a staggered process as the NGL from the chiller are fractioned into the component ethane, propane, butane, and they have to go through a different stage, step by step, and arise the liquefaction process where the remaining feed gas take place in the main cryogenic exchanger, which is most plant consists of a spirally wood tube bundled inside an aluminum shell. It is called as a MCR, which stands for a multi-component refrigerant, and pass through a different cryogenic exchanger. Again, it is a staggered chiller. Feed gas enter to the lower bundle at minus 45, passing up through the middle bundle and the front bundle, where it is cooled approximately at minus 162 degrees Celsius. Here we will work especially on cryogenic, including full nozzle valve, what I will describe just later. But before talking about product, last stop is storage. storage where the valve will, where the gas will be stored at low pressure, where we'll find a boil of gas, maintain temperature and pressure in the storage system. So it's typically where we will find a low pressure application before transportation. Before talking about product, let's talk about market trend. Why finally LNG is also a concern, which is supposed to be as high as CO2 emission. For people who are not aware, it's one of the topics that has been discussed during the COP28 in Abu Dhabi, where world leader and policymaker came together and committed to rapidly reduce methane and other non-CO2 climate-altering gases during the coming decade. And over the $85 billion mobilized to support this transition, 1 to 2 billion will go toward cutting emission on no CO2 greenhouse gas, such as methane. The reason is methane is 84 times more powerful than the carbon dioxide for the first 20 years after its release. And methane emission come at any stage, from extraction to transportation to processing. So there is some part where our valve will be specially installed, especially during transportation, processing, not really during production, unfortunately, and where Trillium has a role to play. Now, and before starting about products, let's look at the demands. Of course, as most of you are aware, in this energy transition, we are looking for green energy, but it can be the solution of 100% green is not still active. So that's the reason we need to combine it with still fossil, even if we will get out fossil use. But LNG is part of the solution and continue to grow. On a valve perspective, the figure that are released is only for valve business. For the next 5 years, we have a peak in 2028 with over 200 million project investment that are expected. And on the right side, you have the billion cubic meter of LNG that should be produced that are expected by until in the next 2 years, 2024, 2025. So quite accurate. And as we can see, it is largely driven by USA, Qatar, in Middle East, Canada, and China. So how can Trillium support on this mission, on this challenge to make process more efficient and reduce total cost of ownership? We offer different kind of solution. Spring-loaded pilot-operated valves. Spring-loaded is an entry-level, internationally recognized because it is in compliance with recognized standard API standard 526 standardized center-to-face dimension. The design is quite common, full nozzle to reduce the number of weighted parts, body bolted connection, adjusting ring, metal-to-metal seat, even if it's not probably, which is recognized to withstand the highest tightness. In the long-term perspective, that's the right choice because soft seat can be used, but in the long term, it can be damaged, and in that case, the leakage will be higher. But it can be combined with soft seat, by the way, up to 93%. And on that case, we use specific one that can meet those cryogenic conditions. Material selection, due to the reduced weighted part, we can easily play on material selection. My colleague will also talk about material, which can be very extensive from carbon, stainless, nickel alloy. We can offer different solutions as a bonnet spacer. It's one of them to protect the spring. The function of any safety valve, for those who are not fully aware, is to protect equipment against overpressure. So make sure the valve offers the same performance, the same safety criteria, sorry, not performance, means open at the right set pressure and release the right capacity. And to do this, we need to make sure that the spring stiffness is still the same, unchanged, and that's the reason it can be quite relevant to protect against cryogenic condition, because if the spring cool down, the stiffness increase, and the safety valve stay in close position, what is obviously not expected. Same function for the 9 series. So 9 series is a thermal expansion valve for those who are looking for a smallest capacity, contrary to the star flow for large capacity where we can also go beyond API limit. So same features, except we can same option as well with the spacer, but it can be also combined with a specific connection, unique connection we are providing to a dedicated OEM to make sure the valve keep a perfect tightness. It is our role to propose solution to look at external tightness, but also connection with piping, which is especially appreciated as well. So we use free union as an example for such kind of application, LNG application. So if our two solutions, spring-loaded and pilot, offer the same safety function, pilot raise the bar in terms of performance. Spring will be better in terms of robustness and temperature compatibility, even if we can now meet the same with pilot, putting in place different kind of option like cooling coil to protect inside the elastomer. Pilot is definitely better to increase the tightness, withstand highest back pressure, and also offer a better pressure size and capacity size ratio. Even if when you look at pilot, you can feel, okay, there is a lot of components and the risk of failure is probably higher. What we also put in place here in terms of robustness, it is not so robust. If you put one single pilot to offer the same function than 2 or 3 spring, you reduce the valve quantity and then you reduce the risk of failure as well. So that's typically solution we offer, and that's the reason pilot is a must to have when you have to deal with a cryo as well. Without talking about option, field test connection, high pressure loss, pilot is the right solution if you want to stabilize and make your process more smooth. Uh, avoid shattering. We offer different kind of pilot. Main valve pilot, that's the difference. Pilot is pilot. It can be either pop action or modulating action. Pop is quite popular for gas. Modulating is better because it's only release the quantity you need. So we talk about greenhouse gas emission, reduce fugitive emission. So modulating action is something you have to consider if you want to reduce that and to meet this challenge. There is different also kind of main valve. So full nozzle is one of them. Semi-nozzle is the right one, the unique one recognized as per API standard 526, but it's allowed to reach highest pressure size rating, but it doesn't offer the benefit of the full size, the full nozzle, sorry. As a full nozzle, reduce the number of weighted parts and is also better because you don't have, you reduce the quantity of gaskets. So we prefer to work on full nozzle when we have to deal with LNG process. For the same reason, we propose a full nozzle star flow spring type. Same valve structure, same application. 78 full bore is an alternative solution. This valve is definitely out of API, but provide extra capacity while having smaller inlet size and less weight compared to over API RFIs. It's definitely a valve for end user who are looking for a solution that will reduce their operational cost, moving away from API requirements, and still looking for high tightness to reduce GHG gas. We talk about from the moment from high pressure, but it will be miss the low pressure application. So 74 series is completely for another process. It's for tank storage, the last step and on the LNG when we liquefied and before regasification. It's operates at lower than 15 psi, so out of ASME pressure range. It's a cost-effective technology again because here we use flowing pilot with boost the modulating action. Sorry, so it can be ever compared to a typical weighted load that exists on the market. 74 series is stable near to the set pressure and act with the simple rules. The highest pressure, the better bubble tight the valve will be. So it's over premium performance in terms of tightness, combined with a very limited overpressure needed to release the complete capacity. It's help to reduce, to optimize the tank holding time and reduce emission. So high accuracy, easy to set. That's the solution for tank storage, which is more and more used. All these things will be nothing without talking about the process. We can talk about product, but it's nothing without process. In Sarrazin, we have dedicated employee, and because it's a clean gas, methane is algae, it's a clean gas, we need to make it assemble on a cleaning room where people are especially trained. We have a white room with a clean crane, clean test bench, clean assembly area to make sure there is no dust inside. Any dust, we can talk about lapping and make a specific valve clean. As soon as you have air or dust on the seat, its leakage can occur and you can fail your fugitive emission test. So it's something we need to pay attention. The grease as well should be specially select to match with a cryogenic condition and prevent against clogging. Packing, because it's also Trillium responsibility to make sure the valve keep its cleanness. And we have some solution. So on the pictures you have tap, but we also for upper level we have a double packing system, seal with a sealant between both. All that are cryogenic testing using a boil off. So the fluid is at the real process condition. We follow ISO 13648 to do that, to pass the test. And it can be combined with a fugitive emission test where we will use nitrogen to push on the helium and make the valve perform the tightness test as per API standard 527, the one you have on the pictures on the left side, but where we inject helium inside to make sure valve is tight internally, but also externally. And now, with it said, I will hand over to David to look at the study case for a control valve.
Okay, Sebastian, thank you. So we'll look at our control valve products that can be utilized within the LNG process, in particular in the receiving and regasification side of things. So within the Trillium product portfolio, we have a number of products which we'll briefly summarize on this slide. So starting on the top left-hand side, we manufacture a range of butterfly valves suitable for cryogenic applications and LNG. Now, these butterfly valves could be either for on-off isolation, or in a lot of cases, we manufacture butterfly valves specifically for control applications where we have high flow rates and large diameter butterfly valve requirements. In these cases, a butterfly valve could offer a cost-effective alternative to a globe control valve. So on the right-hand side, we have one of our typical globe control valves. This is based on our standard series BV500 or BV990 with special adaptations to make it suitable for cryogenic and LNG applications. So as you can see, we have an extender bonnet. The extender bonnet is generally specified to BS6364, which is usually within the customer's specification requirements. In this particular valve, we also have a drip tray, which again are usually specified by customers, depending on the thickness of the insulation. They generally identify an ideal location. These can even be provided on like a 45-degree angle in some cases. So again, very unique to the individual customer or contractual requirements. And another feature you can see on this valve, which is another important consideration within the LNG market, is actually testing the control valve. So on a lot of receiving terminals in particular, butt weld ends are specified. Obviously, you remove the flange, you remove any potential leakage through a gasket. So butt welds are generally specified. But you have to consider then how you would test the valve with the butt weld end connection. So this can either be through a special clamp connection, which would allow you to mechanically clamp the test plates in place. Or in this case, we've actually welded extended spools onto the valve in accordance to the customer's requirements. And what we would do here is test the valve under the cryogenic conditions and then actually machine the blank ends off and prep the weld ends with the required butt weld connection. So it's always important at the beginning of a project to sort of consider the cryogenic testing requirements, because it may not be required on every single valve. Generally, a compromise can be reached where a valve of each size and rating, for an example, is cryogenically tested to prove the other valves of the same design. So in the center, we can see a valve that's just undergone cryogenic testing, similar to the requirements that Sebastian's already mentioned in terms of clean room assembly, drying the valve prior to cryogenic testing to ensure you don't have any frozen liquid in there. And this valve's just been taken out of the liquid nitrogen bath, and you can see the ice formation on the valve. And on the bottom left-hand side, you could see a cryogenic cold box. Now, the valves installed within this cold box are again butt weld connections within the cold box, but the extender bonnet extends outside the cold box, and the expectation from the customers in this case is that the control valve trim can actually be removed and maintained from outside the cold box without having to enter the cold box for any maintenance requirements. So these types of valves require a special trim requirement. Okay, next slide. So further considerations for valves for the LNG market. We discussed already BS standard BS 6364. Like we mentioned, this is generally in customer specifications for LNG. Just an interesting point there. One of the main reasons for this is that Great Britain was actually importing LNG as far back as the 1950s from the Middle East. This was before the discovery of the North Sea gas. So obviously standards had to be written to cover the equipment within this process. And that standard's still the dominant standard for certain elements such as testing and bonnet lengths. We also have to consider the materials that have to be suitable for the -196 design temperature. And the materials also have to be impact tested at that temperature, along with any welding qualifications that might occur in the fabrication of the valve. They would also have to be tested at -196. So a typical size range on a receiving terminal, we're talking valves 1 to probably 16 inches standard, as high as 20 inch on rare occasions. And pressure ratings, because of the pressure of the compressed cooled LNG, we're not normally talking above a class 900, so class 150, 300, 600 are typical on this type of application. So in terms of trims, again, we can utilize a standard trim technology with minor modifications in terms of seals and gaskets, again, suitable for the operating temperature. So a typical control valve in an LNG service would be a relatively low pressure drop. So we can utilize our standard multi-flow cage, which is a drilled hole single stage trim. This will probably cover 80% of applications on an LNG receiving terminal. We do see some higher pressure drops, particularly on pump recirculation valves. Most of these can be covered by our cascade trim, which is a multi-stage trim and just ensures that there's no cavitation of the LNG and also noise levels are within acceptable levels. The more severe valves that we see on an LNG receiving terminal are a tank pressure control valve. These can reduce pressure from 78 bar down to atmospheric. And whenever you're reducing a gas pressure down to atmospheric, you're always going to have issues with velocity and potentially noise. So for these applications, we can introduce our extreme severe service trim, which you can see on the bottom right. This trim reduces the pressure over a number of stages and manages the velocity of the gas as it as the pressure reduces across the trim. And it also ensures the noise levels are within acceptable levels of the standard. So another fairly unique product that we manufacture within Trillium are desuperators for cryogenic and LNG applications. There's not usually a lot of these on each project, but they can be quite technical and require rather bespoke designs. So typically these are used where you have boil-off gas on a project, and it may be the sort of storage areas or on transportation. And for the efficiency of the process and the project, the boil-off gas can actually be cooled and turned back to LNG liquid. And the first step of this process is to cool the gas itself. So for this purpose, LNG is actually injected via the desuperator into the boil-off gas stream to cool the gas. And with any type of desuperator, so typically you're injecting a cooler water into a steam pipeline. Atomization is the key point, really, to ensure that the LNG or the water is fully vaporized and absorbed within the gas stream. So on the bottom left, you can see a rather high capacity valve that we've manufactured here for an FLNG project. And this required many spray nozzles within a 4-inch desuperator pipe that was injecting into a 24-inch pipeline of gas. And on the bottom right, you see a fairly standard variable nozzle probe type desuperator for lower capacities. Okay, next slide. So moving away from the LNG process, but one of the more severe services that you would see on an LNG receiving terminal is associated with the open rack vaporizer. So the open rack vaporizer uses the heat within seawater, so typically 5 degrees or more, and that is used to evaporate the LNG. So the seawater is drawn from a seawater intake. So these are typically near the coast, obviously, because the LNG is shipped in. And then the seawater is sprayed via the spray nozzles at the top of the evaporator onto the pipes that contain the LNG, and the LNG then evaporates back to a gas. The reason this can be a severe service, or the reason why valves are quite commonly misspecified, is because they're generally a large diameter pipe, so 24-inch to 30-inch, and obviously seawater is corrosive. So the typical specification here is a rubber line butterfly valve with an alley bronze disc, generally because this is the cheapest option, but this can lead to issues for a number of reasons. And on the center at the bottom there, you can see a valve that's been in this process, and you can see the damage on the edge of the disc. Now, this can be attributed to number one, it could be cavitation, because you're taking the high pressure discharge from the pump and you're reducing it down to atmospheric pressure at startup, because there's no back pressure from the spray water nozzles in the evaporator. And the second common issue is that the seawater pump lifts vast volumes of seawater, and it can also bring in a lot of debris. And in certain cases, you can actually have mussels and shells coming through the valves. And if you can imagine a soft alley bronze disc, that is going to damage it, and instantly you're going to lose shut-off performance. And that disc can actually rip the rubber lining, which allows the seawater in contact with the carbon steel base. So on a couple of occasions, we've replaced incumbent valves of the rubber line design with super duplex butterfly valves, so super duplex base material for the body and the disc. And the other important feature of this valve is the vari-diff vane. So this is essentially an anti-cavitation feature on the butterfly valve, and this also extends the rangeability of the valve. And what this does, it when the valve's first starting up and the pump's first starting up, and you have a low flow rate and a high pressure from the pump, the flow is reduced through the drilled hole section on the edge of the butterfly valve disc, and this reduces the potential for cavitation at these operating conditions. And then when there's full flow from the pump and a low pressure drop across the valve's in the open position, it has a high capacity. So it's very good for any discharge pump application. And with that, I believe I am passing over to Jiska to go for the RedPoint product range.
Yes, thank you, David and Sebastian. And welcome everybody. So just a note to that you are able to put all your questions and comments in the Q&A section of this webinar, so we can address these at the end of the webinar. So please share your questions that you have. So I'm going to talk about RedPoint. So Trillium's legacy brand RedPoint, with its factory located in the Netherlands, has over 35 years of experience making valves for all kinds of critical applications in the oil and gas and the chemical industry. And this also includes valves for cryogenic applications such as liquefied natural gas. Every valve that RedPoint makes is made to client specification and fit for their purpose. And RedPoint has a focus with its unique selling points on quick delivery times. So the scope of supply for cryogenic valves consists of ball valves, gate valve, globe valve, and check valves. And you also see on the slide double block and bleed valves. They can be used, of course, for efficiency in weight, cost savings, or space. And RedPoint can take care of actuation where required. And for specific cases, we can also design tailor-made valve solutions, which are more engineered products for the client. And for cryogenic applications, we go up to 6-inch in size, and pressures go up to class 2,500 pounds, which is approximately 430 bar cold working pressure. So if you look at liquefied natural gas applications, RedPoint valves can or will be supplied with specific design features to ensure a fit-for-purpose product. For example, bonnet extensions ensure the stem packing stays on the right temperature to function properly. Drip plates are usually supplied for valves and insulation. Due to the low temperatures, condensation can occur, and such a drip plate then prevents water to run by the stem and freeze up in the insulation at the bonnet. Ball valves are equipped with low friction stem bearings, so you can ensure the smooth operation and low torque even at low temperatures. Another feature is the gland plate construction for easy retightening of the stem packing, which is then independent done of the stem. So there will be no additional stress on the stem while tightening the stem packing. Non-rotating rising stem are not only applied for gate valves, but we also do them for globe valves. So this way there are only linear movement of the stem. So there's no rotating movement against the stem packing, so it gives less friction on the stem packing, which has a better durability, lower leak rates. Lip seal design, so that's used for ball valves. RedPoint uses these typically on Trillium mounted ball valves or metal seated ball valves with seat holders as a seal in the seat holder, because O-rings will lose their flexibility at lower temperatures. And lip seals have a metal spring around or inside the elastomer, and in that way the lip seal will also keep shape in very low temperature applications. So RedPoint valves also have a special cryogenic seat design. This is a seat shape developed by RedPoint engineers for soft seats to reduce torques and also improve flexibility of the seats in cryogenic conditions. This is specifically developed for this application, but it can also be used for other applications. That is really specific for RedPoint valves. And sometimes end users require a vented hole in the ball to relieve possible cavity pressure buildup with soft seated ball valves. This basically makes the valve unidirectional. It's no problem for us to do. But these soft seats that we have designed and also tested are self-relieving, and therefore a vented hole in the ball is not necessarily required for RedPoint valves in cold applications. So the materials, austenitic stainless steel, that is typical for liquefied natural gas, for example, 316 stainless steels, but we can also supply other types of stainless steel, such as 304, 321, 347, nickel alloys in different variations. So that is also sometimes requested. Impact testing, also mentioned by David, we do that as well for low temperature applications where required by the standard or upon request of the end user. Soft seat materials is also available in various types. We prefer to use up to class 600 pounds TFM, so that is modified PTFE. Above, for example, RPTFE or normal PTFE, because it has the strength of RPTFE, but it has much better mechanical properties, in our opinion and experience. For higher pressures, PCTFE is also very suitable for cryogenic applications, and Teflon we can use that as well. And especially for higher pressures, that is more recommended, so above the class 600 pounds. And other materials are available upon request to suit your requirements. So design and product validation are, of course, very important from quality point of view, but also from safety perspective. These are some examples that can be applicable for low temperature applications. Low temperature testing is usually done with nitrogen to test the seat leakage and sometimes to test the body integrity as well. David also mentioned that hydro testing on the valves. We think it's not always recommended, especially when you're going to perform low temperature testing afterwards, because in small cavities, water can stay behind. And of course, when it freezes up, it will expand and can cause damage in the valve. So sometimes we prefer to use a gas test at ambient as well before the low temperature testing. Fugitive emission testing is of course important, and that's done with helium or methane to ensure the valve is tight to the outside atmosphere. Typical standards for that are ISO 15848, API 624, API 641 for ball valves. Fire safe testing, also pretty important with the liquefied natural gas. That is done to test the sealing capability of a valve after being exposed to a fire. This is usually done on soft-seated ball valves due to the presence of elastomeric materials in such valves. Impact testing, done on the raw materials to ensure mechanical properties at lower temperatures. And non-destructive examination is a collective name for examinations of a product or material without causing any damage to it. Examples are a liquid penetrant examination, which is a surface examination, PMI, which is a chemical analysis of the material, and a radiographic or ultrasonic. So that way you can look for irregularities inside of the material. So that are examples for such tests. So I choose for red point valves. I mentioned that when short delivery times are required, that's our focus. So when a valve is not available from stock, Redpoint can help to avoid any delays in the projects or unnecessary downtime, because we can produce valves quickly. Valves that are difficult to source, so the non-commodity products, which means you will receive a quality valve made to your specification, and quality materials and quality production. So I've also added low cost of ownership. And you will get a product from Redpoint which helps you with your to prevent any downtime, and also make sure that it has a long lifespan and fit for purpose, which is also a safety factor. The valves are made to specification and application, and are safe to use for your plant personnel and also for the environment. So this slide is a case study that we wanted to show. Our case study that we wanted to show is about type approval testing. Although production testing on valves is important, as a valve manufacturer, we also want to have the confidence that our clients receive valves according to the standards that we promise. And in this case study, I want to show how we have validated our design for cryogenic ball valves to ensure the valves are safe to use under any circumstance. And to do this, we have used a procedure from Shell, which we see a little bit as a benchmark, which is their SPE 77300. And this is a procedure for type approval testing or design validation testing for valves. On the right, you can see the synoptic table for this test sequence. It shows 4 cycles at various pressures, temperatures, and holding times. And all these are with very stringent leak rates. And the test temperature that we did was minus 196 Celsius to plus 80 degrees Celsius with a pressure class of 600 pounds, which is also very generic for liquefied natural gas applications. So for the next slide, I wanted to go a little bit deeper into the 4 test sequences that we have done. The sequences consist of 19 steps in total, and the test medium is nitrogen. And every test sequence of the synoptic table takes 1 day to do. The first test was done at ambient, where the run-in, as you can see, the cycles were already 100 cycles. And after that, the seat sealing is tested at various pressures from 2 bar to 110% of the nominal pressure with 5 minutes holding time. So that's longer than what you normally do on a production valve. And also the body integrity was tested with helium with a holding time of 15 minutes. And after that, the valve is cycled another 25 times, whereafter the fugitive emissions are measured with helium. So the first sequence is finished with another seat test at 99 bar and 5 minutes holding time. And for all seat testing, 0 leakage is required, as you can see on the right with acceptance criteria. And no visible leakage was also detected in the column on the left next to that. So that was a pass at ambient. After that, we did a test. The next step would be testing at minus 196. That was the next day. So the valve will receive there the same difficult test sequence that it had the day before, but this time at low temperature, minus 196 Celsius. And although this cryogenic tested for this cryogenic testing, some seat leakage is allowed. You can see that our valve in general had no visible leakage reported. So that was also a very good result for us. And then the third day, that's the test day where the valve is warmed up to elevated temperature, in this case plus 80 degrees Celsius. The valve got a similar test sequence as for the ambient and the cryogenic temperatures. Again, the valve showed no leakage during this sequence, and it was also not allowed according to the standard. So all still done with nitrogen. And on the last day of the test, the fourth and last sequence consists of another ambient test temperature with seat sealing tests. This is done at low pressure, but also at high pressure, all with 5-minute holding times, and again, 0 leakage allowed. So as you can imagine, this 4-day long type approval test is very tough to succeed. But for us, it was a way to challenge that our quality and safety standards are met for these kind of services. So today we talked about the liquefaction process, the current market trends. We've also gave an overview of the Trillium's legacy brands, the product lines for LNG being pressure relief valves, isolation valves, control valves, and check valves. And we hope you have learned something new today in this webinar, and look forward to work with our partners in this challenging and growing market. I wanted to take a little bit more at the Trillium Flow Technologies value proposition to end up with. First, we have defined what an end user would benefit from in their process. So emissions are mentioned, so to help control internal and external leaks. Not only are fugitive emissions responsible for global warming, controlling emissions has a direct impact on plant efficiency and also improves safety for personnel and surrounding residents. The ease of maintenance. So reduce operating costs by implementing a valve specially designed to minimize downtime, thanks to engineered solutions and enabling rapid maintenance. And overall performance. so to optimize overall plant performance for cycling operations. So this means increasing plant efficiency with appropriate control valve solutions that Trillium can supply. And what can you expect from Trillium? Well, we have knowledge for material selection. We know the testing requirements. We can select the right technology, or at least advise on that based on the requirements, which could include tailor-made solutions that are fit for purpose. Our teams are trained and engaged to deliver high-quality products and solutions, and we deliver service. So we are well aware that our solutions involve directly safety and potential downtime. So this is the reason why we have the processes in place to supply service to end user with the needed spare parts, as well as on-site service possibilities. And this combination ensures to the end user in terms of their general process, maintenance, reliability, and compliance, also with local regulations regarding the reduction of emissions, the benefit of using Trillium. So with that, we come to the end of the webinar, and yeah, I would like to start off with answering any questions that you might have on this topic. And thanks again for everybody to attend, and yeah, hope we can yeah, talk to each other on a later stage.